All right, we're now into the last lesson for this unit, putting it all together for sketching the graphs of rational functions. Okay, so we got all kinds of things we need to do here. We've already talked about this, determining the holes in vertical asymptotes. We've already talked about this, how do you do the equation of the horizontal or oblique asymptotes. Now what we need to do is figure out the behavior of the graphs. So this has to do with making a sign diagram, and we also have to find the intercepts. All right, so we're going to take a look at these examples and go from start to finish on how to graph them. Okay, step one, factor. So x minus 4, x minus 1, 1 minus x. Okay, if you take a look at this, let's take a little aside here for a second. Do you remember what happens when you have x minus 1 divided by 1 minus x? That those are actually the same. All right, take a look at this. If I write this as x minus 1, if I factor out a negative from the bottom, I end up with negative 1 plus x, which if I change the order, I get x minus 1 over negative 1 and then x minus 1. These are actually the same, and I'm just left with negative 1. Okay, so you need to remember that. If I look at this question then, and I see this, I'm going to say that cancels out. So I'm left with y equals x minus 4, and there's a negative 1 here, but I'm just going to put that negative 1 in front, like this. Okay? Now hopefully that makes sense to you. So what's happening then? Well, let's take a look first of all. X cannot be 1. That's from right here. Okay, what is happening at 1? There is a hole. At 1, comma, put in 1 right here. I get y equals negative 1 minus 4. This is going to be 3. Okay, so I have a hole. And then, do I have a horizontal asymptote? Well, I'm graphing this now. That's just a line. There's no horizontal asymptote there. Okay, so let's graph that line. Y equals negative x minus 4. I think the best way to do this is to find the x and the y-intercepts, because we're going to get used to doing that for all of these. What is the x-intercept? Oops, that shouldn't be a 0. X minus 4. Okay, so 0 is negative x plus 4, so x is 4. What's the y-intercept? Looks like the y-intercept is 4. Okay, so we have an x-intercept that is 4. We have a y-intercept that is 4. And we're going to have a line that goes through there with a hole at 1, 3. Okay, there's our graph. That's our first rational function. Let's try the next one. Okay, I'm going to start by factoring. Okay, nothing cancels out. I can see that x can't be plus or minus 5, and there will be vertical asymptotes at both of these. At x equals 5, at x equals negative 5. Let's draw that. And it's a good habit to get into labeling completely. Okay, next. Is there a horizontal asymptote or oblique asymptote? What is the degree? 2 over 2. If the degrees are the same, what happens? If the degrees are the same, you have a horizontal asymptote at y equals, and you look at the coefficients of that lead degree. What is the coefficient of this term? It's negative 2. What is the coefficient of this term? 1. So we have horizontal asymptote at y equals negative 2. All right, well that doesn't really help us with the way the graph looks. Let's do some other stuff now. Let's figure out the x-intercept and the y-intercept. Okay, the x-intercept, y will be 0. Okay, and I'm going to use my factored version already. How do we solve that equation? Well, let's turn this into a fraction and cross multiply. If I cross multiply, I get negative 2x squared, and if I cross multiply here, I get 0. So, divide by negative 2, x squared is 0, take the square root, x is 0. There is an x-intercept at 0. Put that there. Y-intercept. So we're going to make x be 0 here. Okay, and then we'll have 0 minus 5, 0 plus 5. So you get 0 over negative 25, which is 0. Okay. Does that help? Is that enough to draw this? Well, I think the next thing you should do is look at a sign diagram. Okay, we'll do a sign diagram here. And what values go on this line? Well, anywhere where the sign could change from positive to negative. And if you look at that, what are these always going to be? They're going to be vertical asymptotes and x-intercepts. Okay, always. So we have negative 5, 0, positive 5. Okay, and we're going to test points. We're going to test negative 6. We're going to test, I don't know, let's say negative 1. We'll test positive 1. And we'll test positive 6. And where are we going to test those in? Well, our equation, the factored form, is this. Okay, so we're going to put negative 6 into here, here, and here. Remember, I don't care about the value, I just want the sign. So, what would you get? If you put a negative 6 in here, negative 6 squared is positive. The top would be negative. If you put a negative 6 in here, you're going to get negative and negative. So we end up with negative there. Okay, let's put in a negative 1. You're going to get negative, negative, positive. This turns out to be positive. Okay, let's put a positive 1 in. You're going to get negative, negative, positive. Again, this is going to be positive. And if I put a 6 in, I'm going to get negative over positive, positive. So this is negative. Okay? I hope you understand what's going on with that sign diagram. Maybe I'll emphasize this one a little bit more and just show you what I'm doing. So I'm putting in a negative 1 where the x is. Okay, and then if I'm simplifying this, I get negative 2 times positive 1. I get negative 6, and I get positive 4. And you can see this is going to give me a negative 2 over negative 24. This turns out to be positive. So that's what I'm doing when I'm doing a sign diagram. Okay, so how does that translate to a graph? Well, let's do this section right here. It's positive, and it's touching the x-axis at 0. So how do I know it looks like this? Well, it has to be positive. It can't be down here. Okay. There's also asymptotes, so I have to have asymptotic behavior. I have to approach the asymptotes. Okay, let's do this here, where it's negative. Well, if it has to be negative, could I put the graph right here? Well, no, that has an x-intercept, and I already found out there's no x-intercept there. Could I try to make it like this? Well, this isn't an asymptote, so it can't be approaching there. If it's got to be negative, it's got to be in this area down here. That way I can approach both this asymptote and this asymptote. Okay, and the same thing over here. And there's our graph. That's probably one of the trickier ones. Okay? Next one. Again, start by factoring. Okay, you know what? I don't like that negative in front. I'm going to factor out the negative, and then I'll factor it the next step. You don't have to do it that way. I just find it easier. So 2x and x, this is minus 2 minus 1, and x minus 1. Okay, no common factors. X can't be 1, so there's a vertical asymptote at x equals 1. And then we have to decide what's going on for horizontal or oblique. If you have degree 2 over degree 1, what does that mean? That means we have an oblique asymptote at y equals something. How do we figure that out? Synthetic division. Okay, so I have negative 2, 5, and 2. Notice I'm taking that right out of the original. Oh, it's negative 2. The original equation. Okay, so negative 2, 3, 3, remainder is 1. Again, I don't care about the remainder. I just care about this. This tells me I have an oblique asymptote at negative 2x plus 3. Okay, so let's draw those two things in. I have a vertical asymptote at x is 1. And I have an oblique asymptote here at negative 2x plus 3. Very quickly, let's figure out the x-intercept and the y-intercept of these. The y-intercept is 3. The x-intercept is 3/2. Okay, so here's 3/2. It's a little bigger than 1. And the y-intercept is 3. Okay, and this is an oblique asymptote. Remember, that's not the graph, that's just where we're going to have asymptotic behavior. Okay, what next? Now let's find the x-intercept of the graph and the y-intercept of the graph. So x-intercept, we make y be 0. And my equation is, let's take the factored form. Negative 1, 2x minus 1, x minus 2, over x minus 1. So again, cross multiply. I end up with 0 equals negative 1 times 2x minus 1, x minus 2. So either 2x minus 1 is 0, or x minus 2 is 0. So x is 1/2, x is 2. Let's put those on the graph. X is 1/2, and x is 2. The y-intercept, okay, you're going to get negative 1 times 2 times 0 minus 1, 0 minus 2, over 0 minus 1. What does this equal? Negative 1 times negative 1 times negative 2 over negative 1. So I think that's just 2. Okay, so I'm looking at this graph. I don't even know if I need a sign diagram. I mean, I know I have to go from this point to this point, and you can kind of see it's got to follow to the asymptotes. Okay, so I'm going to draw that in here. It's going to look something like this. Okay, and approaching the asymptote up here. Just a quick note, when you're drawing, your line should be approaching the asymptote. Okay, you don't want to curl away from it like this. All right, and it shouldn't cross either. Now looking over here, I know I have to go through this point here. So realistically, could I do something like this? Would it come like that? I don't think so, because it's crossing an asymptote. Okay, I know that it has to go through here. It looks like it should approach this asymptote, and it should approach this asymptote. Okay, a quick check of my graph shows me that this is a continuous graph except for one break. There is no value at x equals 1. Okay, but everywhere else you can see there's a continuous line like this, and then a continuous line like this. The graph continues all the way from negative infinity all the way to positive infinity. Okay? If you wanted to do a sign diagram as a check, let's quickly do that. What would be my values? I would put 1/2, I would put 1, and 2. Again, the only things that go on there are the x-intercepts and the vertical asymptote. The oblique asymptote, I don't put 3/2 here. Don't do that. Okay, so quick check. If I look at those values, you're going to get positive, negative, positive, negative. Okay, so there's our next graph. Okay, just a quick comment about oblique asymptotes. Usually those don't show up on the exam, but I for sure will have one on the test. Okay? All right, last example. Y equals x plus 3 over x plus 3, x minus 3. All right, canceling these out. This means we have a vertical asymptote at x equals 3. We have a hole at negative 3, comma, well, we got to figure that out. Okay, what's left when we cancel this out? 1 over x minus 3. Remember, when we cancel this, this equals 1. Okay, so if I put a negative 3 in for x there, I get negative 1/6. Okay, if you're not sure, quickly do that. 1 over negative 3, take away 3. This is 1 over negative 6. Okay. So, what else do we know? Well, this has a horizontal asymptote at y equals 0. Why? Degree here is 0, degree here is 1. When the degree here is less than this one, it's always y equals 0. Okay, so let's graph that. I have y equals 0. I have x equals 3. And I'm going to save the hole for the end. Okay, let's take a look at what the graph looks like first. So x-intercept, y is 0. And remember, I'm using the simplified version. Whenever there's a hole and you cancel something out, don't use that to graph. Okay, so we have x minus 3. So cross multiplying, I get 1 equals 0. When does 1 equal 0? Well, this is impossible. Okay? If you have something like this where 1 equals 0, something that's not true, this means no x-intercepts. Okay? Now, this is going to mess you up a little bit. You can see there's a horizontal asymptote, so it should make sense that there is no x-intercept, but I'm not going to tell you there never is, because there are examples where there is an x-intercept with a horizontal asymptote of y equals 0. Okay, it does happen. All right, you can have a value on the horizontal asymptote. You can't have one on the vertical asymptote. You cannot cross the vertical asymptote, but you can cross the horizontal. Okay? Y-intercept. So y is negative 1/3. Okay, so there's negative 1/3. Okay, a quick sign diagram. Weird. There's only one value. Okay, and if we put that into the equation, which equation are we testing? We're testing this equation. All right, if I put in 0, I already figured it out. That's negative. This is positive. So let's graph that. Okay, so negative means we're going to be down here. Positive means we're going to be up here. And one thing is missing. Right about here, we have negative 3, negative 1/6. All right, so those are tricky. You need to try a few of these, see how you do. Now I have some stuff in the textbook. Okay, you also should do the multiple choice. There's also a review on page 124. And then the practice test is on 146, I think. These might both be reviews, I'm not sure. But if you're still struggling with these graphs, don't forget I also have a big test review posted. There are lots of examples in there. Okay, make sure you're trying those. All right, good luck with those. We're finished Unit 5. Oh, I forgot one more thing. I will post a practice test as well. Okay? Posted in the Unit 5. All right? Make sure you try that.